In this series, we've taken you through 3 separate videos explaining how to move from a zero to a hero using Genera. In this final video in the series, we're going to bring it all together and demonstrate how easy it is to create and run a process through the Genera user interface. All coming up on this episode of Genera Gems. Welcome everyone to another episode of Genera Gems. And today we're going to wrap up the series related to getting Genera installed and building a workspace and doing robot teaching. And the final piece to this is putting it all together so we can create a process to which we can actually run our science on, our sequence of steps to actually perform actions on devices. So that's what we're going to go through today. And as always, I'm going to let Igor take the lead here and we'll just kind of discuss as we move along. So Igor, have at it.
Yeah, this is super exciting to get into because this is where we actually create the science within the software.
That's right. That's right. So if you can remember, Igor's just picking up where we left off last time at the teach pendant because we taught our teach points in the third part of this video series. So this is where we'll begin.
Yeah, so in order to create a process, that's what we call it in Genera. We need to click this white paper icon in the top left corner. We're just going to click that, and it'll ask us where to save our process. So I'm just going to save it in my 0 to hero processes folder in my processes main directory of Genera. I'm going to call this my 0 to hero process. Very fitting for this. Oh, we'll call this part 4.
Yay.
Very fitting. Yeah. And then, as before, we've created our projects, we've created our layout, and so now we have to select it here. So for every process, you could only have one project associated to it. So this will just be my basic process or basic project. But for our layouts, we could have multiple layouts. So if you have different configurations of the system and you want to select them all for this process, or you just want to select one, usually it's one, but you could select more if you had more layouts. And I'm going to click OK. And now we're here on a blank sheet. And so this is divided into 3 sections. So we have our top left section, which is our control nodes, and our bottom section, which is our activity nodes. Jeff, do you want to give a little explanation on the difference between the two?
Yeah, control nodes do kind of what they explain as far as control over the whole process. So you can see you have things like making decision nodes or an incubation or a process and moving labware and things of that nature. And they control sort of the overall process flow. Down below are the activities, which are related to instruments. There is one category, however, called the general category, which has generalized programs in there to do some unique things, message dialog boxes, generate an error, send a Slack message or something to that nature, which again, those aren't necessarily related to an instrument, but they are programs that fall into a general category.
Yeah, and there's a lot of activity nodes here in our general category that doesn't typically comes pre-installed.
Exactly.
But as we'll get to in the future, Genera has an open architecture which allows you to create your own programs. So to get started, what we're going to build here is a very simple process. So we're going to have a 2 labware process. We're going to have a sample plate and a destination plate, which you would typically see in a simple workflow. And we're going to do some processing on our destination plate. So we're going to add some reagents to it. We're going to add some, we're going to wash it, and then we'll move it to the liquid handler. And then from there, we'll incubate it for a little bit after it's done, moving transferring the liquids from the sample plate to the destination plate, incubate it, read it, and then put it back into the incubator.
That's quite a few steps, my friend.
Quite a few steps, but it's a fairly useful and well thought out experiment here. So what we're going to start typically is we're going to add our lanes. So lanes are associated with labware. So whatever activity nodes or control nodes you put in a lane, it's usually going to be affected to that labware that is selected. And so this lane here, we're going to call this my sample plate lane. And we have a labware selection here. So this is a recent feature here. It's called lane labware. Jeff, you want to explain that a little bit more?
Yeah, lane labware allows the user to select which pieces of labware they want to utilize in that process lane during schedule time. So this is one way to do that. It's the new, like Igor said, this is a new feature. The classic way would be to take a control node called labware and put that at the beginning. But this allows you to make schedule time decisions on the pieces of labware you want to use. And they work sort of similar, but different enough that you can see the benefits of either. So I didn't know which way you wanted to
Yep.
take this, if you wanted to use lane labware or just use a labware node, but you can demonstrate that.
Yep, so we're going to demonstrate both. So for our sample
Okay.
plate, we can use lane labware, and then for our destination plate, we'll use the control node labware. So for this, for the lane labware, we have to specify the location first. So we're going to select a zone, and we're going to select our sample plate input, sample plates, and we're going to add that to our zone
It's important to
and or to our
remember.
location.
Sorry, I didn't mean to cut you there, but
Yep,
it's
go ahead.
important to remember for our viewers that the sample plate zones came from the construction of our projects. So when we were building the project, we created zones, and that's where this actually comes from.
And we could actually go visualize. Oh, I did not select a labware definition. And same with the labware definition, this is also was created in the workspace video. So here I'm going to select my DeepWell 96 as my sample plate. And we can actually visualize the zones if we'd like. If you forget where your zones are located, by going to the Scheduler tab, and then let me just reset this view. And then when under Highlight, I could select my sample plates, and so I could see that my sample plate needs to be in the third incubator here, or in the third hotel of the incubator.
Correct.
And so now I just need to, when I add my plates to my workspace in my scheduler view, I just need to make sure to input that into the third hotel. So now that we've added our sample plate lane, we're going to add our destination plate lane. And this one, we're not going to select our lane labware. We're just going to go straight into the labware node. And for this, you can see that there's more options here because you're letting
Yep.
Genera pick what the destination plate will be. So I like to think of this as a filter. The more parameters you give it, the more honed in it could be to make sure that it picks the correct plate for that lane. So in this case, for the location, we're going to have our destination plate input. We're going to have our labware definition, which will be my microplate 96. I don't think I added this in, so let's click the add button. And then we could do further criteria that we couldn't do with lane labware because we're selecting the labware for lane labware here. We could choose whether it needs to be lidded or non-lidded, choose a certain operational status that could be set in the projects of the workspace. We could choose a barcode, so make sure that it has a certain barcode, or we could choose a custom script here, where as long as it returns, I believe it returns true or false, or make sure that the criteria is set correctly.
Yeah, it's important to remember on this criteria that Genera will look for that particular criteria that you select. Something that's simple to think about. If you select an operational status, if you select that and you drop down on the menu, select there and drop down. If you were to say, I don't know, read ready. Now, what it will look for in Genera for this process lane, it will look for labware with an operational status called read ready. And only when it sees that operational status will it select those plates. It's not something that it's going to assign to that plate, it's going to look for that operational status.
And maybe I'll leave this in so we can actually show this in action.
Sure, absolutely.
When we get to scheduling this process. So I'm gonna add that in. And another note is we don't typically want both a lane labware and a labware node. You usually have to pick one or the other.
But there you can see the classic case of a lane labware doesn't have the labware node traditionally in the process lane, whereas the destination plate has the traditional look to it.
Mm-hmm. So after our labware node, we're just going to go on to our destination plate, since the destination plate has some extra processing that needs to be done before it gets moved on to the liquid handler. We're going to go straight into a decision node. And what this decision node will decide on, right, because that's what the decision node does, is it has a true or false lanes within it. And depending on what you select as your program, script, or instrument command, if it returns true, it'll go through the true lane. And if it returns false, it'll go through the false lane. So for this decision node, I'm going to select a reagent type. Because if you remember from the last video, we could select a labware properties. And so for one labware property, I could actually, let me just add this in real fast, and I could give a little bit of background here. So here I have a reagent type for our microplate 96, which is our destination plate, and it could either be buffer A or buffer B. And so this decision node will check whether we want it to be based off of the program will be condition, and I want it to be is equals strings. And I want A, which is our first string, will be my property, which will be based off of reagent type. And my value for B will be buffer A. And if I was to now click OK, so now if when the labware gets selected from the labware node, if the labware has a labware property of buffer A, then it'll go through the true statement. And if it has a buffer B labware property for reagent type, it'll go through the false statement.
Yeah, a good way to think about this for the viewers again is you do have some decision lanes here or branches. And if you do want to use a labware property to perform specific operations, in the case of a buffer A, that may get a unique operation. You could now put some activity nodes in the true branch that may go for special things to be done on a buffer A plate. Otherwise, you can go through the false branch and just run your standard operation procedure. So this allows you to make decisions at the plate level for things that you want to get done. So that's a good way to think about that.
And to keep this simple, we're just going to add a subprocess here. That's going to be I have two processes that I've pre-created, which will add buffer A or it will add buffer B. I'm just going to add these in. If I want to have child process I'll discuss variables in a little bit. So I'm just going to skip through that for now. And so this one, I could rename this to add buffer A. And then I could rename this to add buffer B, which will be my add buffer B subprocess. And what I could do is I could actually go into the processes and I can see what they do.
And you can see that they don't look much different than what we were just constructing. It's just unique steps. And that's all we're doing here.
So we could see, yep, so we're adding those unique steps. And then the only difference between the two, at least in this case, is that one will move to the dispenser and add the buffer B, and the other one will move to dispenser and choose buffer A. And then this will be a different protocol for each. So subprocesses are very nice to kind of methodize your process so it doesn't look as large in your overall main process. So after we add our buffers, the next thing we're going to do is we're going to add a loop. So just to show another functionality of a control node, And what a loop does is it'll loop through. So if I add this in, so we have two branches here. So if it goes through the inside branch, it'll loop through until the condition is set or until it's false. And then if it's false, then it'll leave the branch. And if it continues to be true, then it'll stay in the loop branch.
Yeah, and then inside that loop branch, again, you can do just what he did on the decision node. You can add activities inside the loop. And there are options to select here. You can do some sort of basic count of loop, or a program to run, or a script, or maybe some instrument command that you have that you want to run. So there's options that you can use for this loop counter, and you can select
Yep.
that here.
Yeah, and what I mentioned about staying inside the loop when the condition is true is only applies to programs, scripts, and instrument commands, but you could just do a basic count. So what I'm going to do is I'm going to go through the variable table now. And this is what I'm going to talk about variables. So variables are nice because you could parameterize variables, so you could get some user input, where in this case, I'm going to have the user define how many wash cycles there should be. So I'm going to call this my plate washing variable, and then I could, add a description if I would like this indicates how many plate washing steps there should be. You could, however else you want to explain that this is for the plate washing. And I'm going to make this into an integer. And then I could give it a default value. So there must be at least one plate washing. And I could parameterize it. Or I can make it a batch. Or I could have it set inside the process. So there's a lot of functionality for a variable.
Yeah, it's important to understand what Igor's just done there. He's created it as a parameter integer variable. So a parameter is something that the user is being required to enter during schedule time. And we'll see this when we actually build it and finish and it actually runs. It will be an integer we're looking for. So in this case, maybe the both of us are running this same process at the end, but maybe Igor only has 5 wash cycles and I have 10. Well, we can run the same process without having two separate processes built. I just change my value to 10 and his is 5. So it adds a lot of flexibility.
Mm-hmm. So I'm going to add this in, and I'm going to click OK. And then in my loop now, instead of having a value for count, I could go through this drop down for this parameter and select my plate washing. And then I could just add a simple, for my EL406, my biotech EL406. So I have this run protocol. I could add that in. And then I could choose my parameter, my protocol file, and then I could also add an operation. So I could add my wash operation on that labware. And now I could add that activity node. So now that this is finished, next, after I'm done with my washing, I'm going to move this labware to our liquid handler. So I'm going to use the flex-1, which is the robot arm for this workspace.
Yeah.
Yep. And then I'm going to move this to my nest 1 of the Opentrons. And then I don't believe this needs a regrip, so I'm just going to leave that empty. And I'm going to add the labware node. So I think we're good for our destination plate for now. And I'm going to go to our sample plate. So as you remember, we have a lane labware selected for our sample plate input. And then to double check, we see that it's on Hotel 3. So we're just going to go straight from the Hotel 3 of the STX incubator and move it straight to the Nest 2 of the OpenTrans Flex, because we're not going to do any processing with that. So I'm going to add this in. Flex 1 will be the mover, and then I'm going to move it to the Flex 2, and I'm going to add the activity node. And then to make it look, go ahead.
Sorry, I was going to mention here, because there can be probably a little confusion. If you go back to the scheduler view and the workspace, And if you notice that what Igor did in that move labware activity, he said move from STX 110 to the Flex Nest 2. Well, you may be scratching your head going, well, what about STX 110-Nest? Well, that is associated with the STX 110 and it will unload to that location and the robot will pick it up there. Obviously, the robot does not have internal access to the STX 110, but that's important to make sure that you understand for those watching and those who may be using some sort of an incubator that you need to establish some external nest, which I think we've talked about this in the workspace development view and layouts, that you have to have some external nest that this incubator can drop off to, which the robot has access to.
Yeah, thank you for that clarification. Yes,
Yeah.
totally forgot about that. But yes, it will automatically unload into the STX1 nest and then move it to the Flex Nest 2 of the Opentrons. So after we've done that, now we could add our Opentrons Flex activity node for, let me just.
I was going to tell you, use the filter.
Yep. I could now, yeah, so you can filter activity nodes because it could get quite long if you have a lot of instruments. So I could just filter it based off the Opentrons Flex, and I could add this in. And then you could add the parameter files, if you have any other runtime parameters. We could actually pass in parameters from Genera to the Opentrons, and then we could also add in files. So to make this look a little bit nicer, because I want to run them both at the same time. So I want this move labware for the sample plate to be in line with the move labware of the destination plate. And this is purely just a visual thing. So what you could do is you could either right click or you could right click on the activity node you want to move, and you could shift right or shift left. So I'm going to shift right. Or to make this go faster, you could click Control and the right arrow key, and that'll move it into the correct spot. So this doesn't change functionality. It just makes it look a little bit nicer, since I know that both these steps are moving a plate to the Opentrons. And one other thing I want is to make sure that the sample plate and the lines or the destination plate are on the Opentrons nest before running this run protocol. Because if I ran this right now, the run protocol will run as soon as the sample plate is on the Opentrons. But Jeff, do you want to explain how we could have it wait for the destination plate before running?
Yeah, and let me preface all that before we show it. Part of the reason we would do this is because Genera will throw every plate at the solution or at the system. So it will get that sample plate pretty quickly because all the lanes will run at the same time unless you have some sort of scheduling or wait signals and so forth. Well, if it got that sample plate at the Flex, Opentrons Flex, yes, it will start that process. But what we're about to show is you can connect both lanes through what we call linking. Now, the reason you'd want to do this is because you don't want your sample plate to go and get liquid out of it when the destination isn't even there yet. Maybe you have a leaky tip or the precious liquid is falling onto the other deck of something. That's a possibility. And you just don't want one labware not to be there or your Opentrons to be moving when another plate is coming in. So what we can do is we can right click on the destination, move labware, that last node, and we say create link. Now what that will do is say, hey, where do you want to go to? So in this case, we want to go to the run protocol. And now that will create a dashed line. So what this does is it now ties these two lanes together, whereas previously they were separated. So yes, the sample plate will get to the Opentrons Flex faster. It has no prerequisite activities it needs to do. It just needs to move out. But on the destination, it does have some washing it needs to do, so that's going to take a little longer. So the sample plate will wait, and once the destination plate arrives at the Opentrons Flex, because of that link, now the run protocol will be activated.
And if I was to add another move labware after this, because I want to move it after it's done with the run protocol, I want to move the destination plate back to a hotel so that it could incubate there for a little bit. To show you our incubation node, we're going to have to add one more link so that this node will wait until the run protocol is finished. So I don't want this
Exactly.
node to run until this is finished.
So now that will
So,
break those lanes apart, and then the destination plate will come out and now get back into its lane, and then it will continue its own processing.
so once we move this destination plate back, well, we could finish our sample plate because now we're done processing it. So we could now move it back to our sample plate zone. So it'll just place it right back to where it began. And then to do our final steps, so I'll go pretty quickly since this is just all drag and drop. We're going to incubate. So we're going to add an incubation node. So for our incubation node, you have to specify a duration. So I'm just going to do a short one in this case. So this is just 5 seconds. And then we can also add over incubation tolerance and look ahead duration. So what these mean is for the over incubation tolerance is how much extra incubation can it do before the system errors out. So let's say this is a very precious sample and it could only incubate for 5 seconds. And I don't want it to go over 5 seconds at all. So if I set it to 0, and let's say the ARM resource is being used up by another process, then in that case, this activity node will error out the system, letting you know that over incubation has occurred, and it's like a reminder to you or a signal that you need to change your process to make sure that the ARM is available before it goes to the before it over incubates. And the way you could solve that is through the look ahead duration. And Jeff, do you want to explain that a little bit?
Yeah, look ahead will just what it states. It'll look ahead to the next node, and it will hold that node and say, okay, nothing can go to the next node that I see for a certain amount of time in this case. So it will always stay open for X amount of time that you defined to make sure that it's available for setting down a plate or getting a plate to it.
Mm-hmm. Yep. And so in this case, it'll make sure that the ARM is available. So if I was to set a 5-second look ahead duration, then it'll reserve the ARM for 5 seconds. It'll reserve the ARM when this starts. So the ARM can't do anything until this incubation finishes. So it's just a way to ensure that over incubation will not happen. And then finally, we could add a lab operation. So in this case, I'm going to add my incubate. And so now it's incubating, and then after it's done incubating, we're just going to move the plate to the reader. We're going to add it in, and then finally we're going to move it back into the incubator. So we're going to set this as my workspace zone, and then we have a destination plate output.
Yeah, so what you see here is, I don't think Igor's quite done yet, but what you see is a very simple process with an interleave between two lanes or an interaction between two lanes with some simple movements from specific locations, and then a movement of both sets of plates back to their original locations.
Yeah, one thing I forgot to add is the read plate, because if I'm going to move to the reader, I should do a read, and then
You
I
should
have
probably
a
do
read
that.
operation. Yes, it's probably a good idea. So it doesn't
That's
just
the
go
most
there.
important part.
Yep. So you get your data, and then it moves to the plate output. And then, as Jeff mentioned about look ahead, so not only is there look ahead duration, but each activity node could have a look ahead, which he explained, which is will make sure that the next nest is available. So Genera inherently has one look ahead. So if it tries to move a plate into the reader, then it'll look ahead into the reader to make sure that there's no plates there, so that there's no collisions. But let's say you want to go further down the line. So if I want to make sure that from the reader, I want to make sure that from the hotel, right? Because this is where the hotel is. It does the incubate. So from the hotel, I want to make sure that the STX incubator is free. Then I could add look aheads to that. So it'll make sure that the reader is free and the STX is free. before it does this movement.
Yeah, and you can see that the line between those nodes is bolder than the other lines. That's how you know there's a look ahead.
Yep. So if you want to make sure that all nests are available before the plate starts, you could have look aheads throughout your entire process. Which is not, if you want to make it a static scheduler, that's what you kind of make it into, is to go, no,
Yeah.
it's very sequential, make sure everything is clear. But if you want to leave it a little bit dynamic but have some static features, you could do that within Genera.
Yeah, and it could be for, in this case, you want the reader to be available. So you're selecting sort of like groups of activities. You want this group of activities to be together and available for an operation to happen because it may have some time sensitivity to it and criticality that you want to adhere to.
Yep, exactly. So now that we're finished with our process development, now we can actually test this out. Well, before we do that, I want to talk a little bit about handlers. So handlers allows you to run certain programs. You can allows you to run a script or an instrument command. So you can run any instrument command here at certain trigger conditions. So as you can see, we have a list here, but the most popular ones are obviously a start, finish, or error. So it's a one-time run at those different conditions. So like, for example, if I want to send an error email, when an error occurs, to notify myself or whoever else is using the system that an error has happened, I could do that here by going to my general category, and in here there's a send email program, and I could see that there's a send error email. So now if I add this handler in, that any error that occurs, it will send that email. And what's
Exactly.
also cool about handlers is that let's say you have another process. So I'm going to open up another process here. So I have a whole list of handlers here. And what I could do, so I have this initialize all instruments. So this will initialize all my instruments that are part of this process, is I could actually copy from one process and paste it to another process. So now this
Nice.
handler, which is a start handler, it will initialize all my instruments that are part of this system. And then let's say I want to uninitialize it, which I have in here. So I could copy and I could paste it. So now I have a start handler, finish handler, and an error handler.
Yeah, it really acts as like a modular portability of activities and programs that you've set up in some other process that you want to utilize for a new one in this case.
And you can do the same thing with variables. So you could copy
Yeah.
one variable into another process.
Yeah. So some of
Okay.
those you don't have to recreate every
Yes.
time.
So now that we're finished, what we have to do is make sure we add our labware to our workspace in our scheduler view. So as we said, so we're just going to test this out with one batch. So one batch will be one time through the process. And so since I need one sample plate and one destination plate per batch, I'm going to just add one plate. And so as we remember that the sample plate input is at hotel 3 of the STX. So I'm going to double click on that, and then I'm going to scroll down. Well, I'll just add this to the second shelf. That's okay. It could be anywhere in the hotel. And I'm going to add my deep well plate. And then you could pre-fill your barcode. And I'm going to leave this to none for now because I know we added the operational status to the destination plate. So we'll just add that in. And then for our destination plate input, we could see that it's in either Hotel 1 or Hotel 2. So I'm going to add this in to Hotel 2 or Hotel 1. And that's my microplate 96. And as we can see here, we have our reagent type. So I could add buffer A or buffer B. So I'm going to add buffer A for, in this case, and then I'm going to leave it to none just to show you what happens if the operational status does not match the operational status criteria for the labware node. Because if you remember, we had a read ready criteria. I'm just going to leave this to none just to show you what happens. And now that we're done, so to schedule that process, we could go to our schedule button in the top left corner. We could browse for our process. So we have our 0 to hero process part 4. So it's validating, make sure everything, so validation has succeeded. If we click next, we have our scheduling configurations. So these are one of the requirement parameters we have to fill out. So we have our estimation. So Jeff, you want to explain a little bit about estimation here?
Yeah, estimation can work to cycle a process, however many times you're going to run a batch count. And it's important to understand a batch count. We consider a batch count as one movement through the entire process. So if he were to put a count of 5 in here, you'd have a total of 10 plates processed through the operation. Now, an estimation will give you the timings from each of those steps that can be set at the task level. Maybe a robot move from one location to a destination maybe takes 30 seconds. Well, you can put that estimated timing in there and then run a batch count cycle of whatever, as long as the estimate checkbox is selected, and it will cycle that time quickly, and it won't look like a simulation. It'll just give you all those times collectively based on the batch count, and it'll tell you I estimate about this much time to do a batch count of what you've given me. So that's how that works.
Yeah, in this case, we're going to leave it unselected because I want to see the plates move around. And as Jeff said, if we click on the estimate, it won't show the plates. It will just show mostly the timing of each individual activity node. We have our name, so I could change the name of this. So I'm just going to leave it with the process name. The batch count, I'm going to leave it at 1 just for testing purposes. I could set priority. So if you have multiple processes running at the same time, it'll always prioritize the one that has the highest priority. So since this is only one process, it doesn't really matter. But if you have more processes, then that's where priority comes into play. And then we can also set priorities on an individual node back in the process editor. We can have it start, so we can have it be immediately, wait for user input, or a specific date and time. So I'm just going to have it start immediately. And then I can have a reoccurrence. So reoccurrence repeats the process at a certain time interval at a certain number of times. So, we like to think of this as like an Outlook calendar. So if I was to schedule like a QC process, for example, like every Mondays and Fridays, so at the beginning of the week and at the end of the week, and I wanted to, I could have it never end. I could have it end after a certain day and time, or I could have it end after a certain number of times. So like after 5 times. And if I clicked OK, we could see here that it says repeat every week on Monday, Friday, 5 times. So, you can do daily, hourly, minutely, when finished, or none. So I'm just going to leave it at none. I'm going to go next. So this is our parameter variable that we've set. So in this case, it's defaulted to 1. So I could increase it to 3, for example, if I want 3 plate washings for this one batch. And here, so this is the new feature here, is our workspace. So you can see our workspace is also in our scheduling configuration, or one of the steps when scheduling a process. So let's say I forgot to add plates to my workspace. I could add it in this step here. So I didn't have to add it in the beginning. I could have added it while scheduling the process in case I forgot that to add plates. So that's a very important step within Genera because you needed to tell it where the plates are located in the software. So since I already did that, I'm going to click next. Actually, what I could do is I could remove this plate here in Hotel 1 because that's not in my system. So I'm just going to remove that. And then finally, we have our lane labware. So this is our labware selection for our sample plate. So as you can see that this is the only plate there, but if I had multiple plates, it'll show all the plates within that location that I specified in that lane labware. And as you can see, the destination plate doesn't have one because it's controlled through the control node.
Of the labware, the labware node, yeah.
Yes, through the labware control node. And so if I add this in, now I can click finish. All my instruments become initialized and it starts running.
And now this is the simulation. You will see labware moving around the workspace view. Um, what do we got there? Waiting for a
Yep.
microplate. Okay.
So we're
Ah,
gonna go a little bit on error handling here. So we can see it's waiting. So it's waiting for an available microplate with the ready operation status. So remember that we made it into none. So because it doesn't find any with a red ready, it's not going to do anything. So now if I was to change this, so since this is a dynamic scheduler, I could change it dynamically by changing the operational status, and I could click OK, and now it's going to start running.
and that's where the labware criteria, it was looking for that particular plate.
Yep, and I think I have an error here. So add buffer A, so expected Agilent Microbiotech flow FX instrument, but found the Geiger Certisflex. I think I just put the wrong activity for that process, but that's okay because we could go a little bit into error handling within Genera. So obviously I put in the wrong activity node because it is currently on the Certisflex node, but I had it, I ran the, if I was to go to the workflow here, you can see that this one is for the biotech multi-flow FX. So I could have, so for the error handling, I could have a reschedule, so redo the entire thing. I could retry this activity node, which doesn't make sense because it'll just give the same error. I could ignore this error, I could stop this batch, or I could stop this process. So I'm going to ignore because I want it to continue on with the rest of the process. That's exactly what I'm going to do. And now we can see so you can see there's a lot of iterative processes with this. So now it's moving to the flex here. So now you can see that the move labware did not run until, or the run protocol did not run until both of them were on it, on the OpenTrons flex. And now it's incubating. Now it's going to move to the reader. It's going to do a read. So here's another error. So for this reader here, it needs to have a barcode. So you can see the labware does not have a barcode. And so instead of ignoring this, I could actually retry if I was to add a barcode. So I could have this be my barcode, barcode A. So now it has a barcode, and now I could use the retry, which is just going to retry that activity node. So I could click retry. And then you can see that one other thing, that we see that there's another error that happened because my error handler went off, but there's no email server found. So I did not set up an email correctly with this. So, but we can see that the handler did run during that error, and it would have, if I was to set it up correctly, it would have emailed me that error message.
Yeah, it's important to know that when we went to the reader and Igor made the change to put an electronic barcode on that plate, that is only the instrument wasn't in error. The activity is requiring a barcode for that. Forever how that reader may run, it may need barcodes. So that's why that is in the code. So he could make that quick change electronically. Now, physically, obviously, there's no barcode, but electronically, we've given it something. And you could say error on there, and you could have that tracked in the recording of the actual process itself. But it kept the process moving.
Yeah, that's the important part, is that we can make some edits on the fly so that you don't have to completely scrap this run. That let's say you were running with 10 batches, for example, and one batch was to error out. Let's say, something happened with the results of the plate, or it didn't have a barcode. The barcode was faulty, it couldn't read it. That you could still continue on with the rest of the batches. It's just that this one batch could you could stop the batch and just get rid of that plate, so it could still process the other 9 plates or the other 9 batches.
Yep, exactly. So, in summation, what you just witnessed is the construction of a process. If you go back to the editor tab, Igor, and we can kind of run through that real quick, you can see he created 2 process lanes with an individual steps within those lanes of the process that he wanted to run. As I like to call it, it's the science behind the process. And this is what everything that he did, a simple drag and drop interface with addition of parameters within those programs and activities to accomplish the things that need to be done in order for you to run the process. So this is how it's all put together. And again, this all really ties together with the three previous videos that we have to bring it all into fruition to how you can become, again, a Genera zero to hero. And this was how we do it. That's all for this video, and we will see you on the next one.